Welcome to Environmental Engineering 1, Module 3, Part 1. In Module 3, we are going to learn about water treatment processes. In the first two modules, we have already learned about water demand and then the system, the surface water sources and the different types of intakes, pumps, etc. In the third module, we are going to learn about the water treatment processes. Then what is the purpose of water treatment process? It is used to remove color and dissolved gases in water. The second purpose is to remove objectionable taste and odor. Then to remove disease-producing microorganisms. Then to remove hardness of water. Then to make it suitable for wide variety of industrial purposes. The purity of water that we already considering is only physical, that is color, odor, etc. Except from that, all the chemical impurities are to be removed and all the microorganisms present in the water are to be removed to make the water to drinkable quality. And these processes we are going to study in this module. And various steps involved in water treatment. First treatment method is screening, then aeration, then plain sedimentation, then sedimentation with the coagulation, then filtration, then disinfection, then softening, then miscellaneous processes like removal of iron and manganese, fluoridation, and defluoridation. All these processes we are going to learn in coming module 3 and module 4. And the first process is screening. This is the first step in water treatment process. All the heavy water logs, leaves, or big particles present in water are to be removed by the process of screening. And then the process is aeration. We are giving more oxygen to the water so that the chemicals present in water will be exhausted up to some extent. And then the plain sedimentation. Plain sedimentation means the settling of the suspended particles, suspended impurities present in the water. Then fourth is sedimentation with the coagulation. The non-settlable pollutants are settled by using the coagulation process. Then the filtration process after coagulation or sedimentation, the suspended particles present in the water is removed by filtration. Then after the filtration, we have to disinfect the water to remove the microorganisms present in the water. Then the softening process. Whether in the cases where the water is hard water, then we have to soften the water for using it for the drinking purpose and for various industrial purposes. Then miscellaneous processes like removal of iron and manganese, fluoridation, defluoridation. These miscellaneous processes are accepted only when these type of impurities or pollution are present in the water. This is the basic structure of a water treatment system. Then first process is screening. Screen is a first unit operation in wastewater treatment plant. Screen is used to remove larger particles of floating and suspended matter by coarse screening. This is accomplished by a set of inclined parallel bars fixed at a certain distance apart in a channel. The picture will be shown in the next coming slide. The screen can be of circular or rectangular opening depending upon the channel shape. And the screen composed of parallel bars or rods called a rack. The screens are used to protect pumps, walls, pipelines, and other appurtenances from damage or clogging by rags and large objects. These are the normal screening process that we are using in the day-to-day life. And there are two types of screening we are going to use, that is coarse screening and then fine screening. The types of screens. There are two types of screens that I have already mentioned, that is coarse screen and fine screen. Based on the cleaning operation, they are classified as manually cleaned screens or mechanically cleaned screens. Then what is a coarse screen? It is used primarily to protect a device and hence used at the first treatment unit. Common type of these screens are bar racks or bar screens, coarse one wire screens, and commutators. Commutators we are going to learn in the next coming slides. They are intended to intercept only grosser floating materials, bigger floating materials. And it consists of parallel iron bars, 25 mm size and spaced at 75 to 100 mm centers. Center to center distance will be 75 to 100 mm, and these bar racks, spaced in such a way that, and this whole assembly is placed in such a way that it is a slight inclined to the water path. This screen can be manually cleaned or mechanically cleaned. Manually cleaned screens are used in small treatment plants. This is a coarse screen. Here you can see the screens are provided in a inclined way, and all the coarse or large impurities are collected in the screen racks. Then grinder or commutator. It is used in conjunction with coarse screen to grind or cut the screenings. We have to remove the screenings and we have to dispose the screenings so that the proper decomposition or proper removal of the screenings are to be done. They utilize cutting teeth or shredding device on a rotating or oscillating drum that passes through the stationary combs or disc. These will cut the bigger sized particles, impurities present in water into smaller pieces. The object of large size are shredded when it will pass through the thin opening of size 0.6 to 1 centimeter. This is always accompanied with the coarse screens. Then fine screen. Fine screens are mechanically cleaned screens using perforator plates, one wire cloth, or very closely spaced bars with a clear opening of less than 20 mm, less than 6 mm typical. Commonly, these are available in the opening size ranging from 0.035 to 6 mm. Coarse screens are first to remove bigger floating bodies and organic solids, and fine screens then remove the finely suspended solids. Fine screens normally get clogged and to be cleaned frequently. These are the pictures of normal screen. Then the first process, screening process is over. Then we have to move on to aeration. Aeration brings water and air in close contact in order to remove dissolved gases such as carbon dioxide and oxidizes dissolved metals such as iron, hydrogen sulfide, and volatile organic chemicals. The air diffused in the water will remove all these impurities up to an extent from water. Aeration removes odor and taste due to volatile gases like hydrogen sulfide and due to algae and related organisms. Aeration also oxidizes iron and manganese, increases dissolved oxygen content in water, removes carbon dioxide and reduces corrosion, and removes methane and other flammable gases. The dissolved oxygen content in water is very much important in the case of aquatic life. So we have to improve the dissolved oxygen content present in the water, and for the drinkable quality of water we have to be a minimum quantity of dissolved oxygen present in water. So the aeration process is very much important in the water treatment process. This is a picture of a typical aerator or aeration tank. Air diffusers are provided for large treatment plants, and air bubbles are released into the tank, and due to these air bubbles there will be much agitation will be formed and air will be diffused into the water. This is also another picture of an aeration tank. Then, chemicals removed or oxidized by aeration. Volatile organic chemicals such as benzene found in gasoline, or trichloroethylene or dichloroethylene and perchloroethylene used in dry cleaning or industrial processes, and it will be useful for the removal of ammonia, chlorine, carbon dioxide, hydrogen sulfide, methane, iron, and manganese. If we are taking water from an industrial area or an industrial pipe outlet, wastewater outlet is placed in the upstream of our intake, then there will be a possibility of all the chemicals present in the water. So we have to remove all these chemicals from the water to make the water in a drinkable quality. Then types of aerators. There are 4 types of aerators. First one, gravity aerators, then fountain aerators, then diffused aerators, then mechanical aerators. The first one is gravity aerators. It is also known as cascades. In gravity aerators, water is allowed to fall by gravity such that a large area of water is exposed to atmosphere, sometimes aided with turbulence. This is a cascade aerator. A large area of water is exposed to atmosphere so that more air contact will be there, then more air will get diffused into the water. Then, second one is fountain aerators. There are also known as spray aerators with special nozzles to produce a fine spray. Each nozzle is 2.5 to 4 centimeter diameter, discharging about 18 to 36 liter per hour. In this, spray aerators are used. By spraying, the air contact will be more. This picture shows a spray nozzle aerator. Then the surface area, that is the water surface area in contact with the air will be more, and more air will be get diffused into water by using spray nozzle aerators. Then the third one is injection or diffused aerators. It consists of a tank with the perforated pipes. What is a perforated pipes? The pipes with lots of holes. Perforated pipes, tubes or diffuser plates fixed at the bottom to release fine air bubbles from a compressor unit, likewise in a fish tank or in an aquarium. The tank depth is kept to 3 to 4 meter and the tank width is within 1.5 its depth. This is the pictorial representation or a picture of a aerator, injected aerator. Then the mechanical aerators. Mixing paddles, as in flocculation, are used. Paddles may be either submerged or at the surface. This is a picture of mechanical aerators. That is, a mixing paddle is used. Like we are mixing in a mixer grinder or producing a juice. We are mixing the water with the air. And the more water is get in contact with the air and more air is induced or diffused into the water. This is the two primary treatments. That is, first one is screening, then second one is aeration. By this, I am concluding this session. In the next session, we will move on to the plain sedimentation part. Till then, take care. Thank you. Bye-bye.